It's there. All right, so let's go over this. Find the Bahnhof power distribution of the weighted voting system. So this section is just got 3 questions, but they're super long. So, that's a hard one. Is there an easier one? Okay, so let's do this. We'll start with number 2. It looks a little easier and why I'm saying it's easier, it only has 4 players instead of 5. 5 is pretty hard. 4 players is more reasonable. So this is a weighted voting system. Remember what that means? It's like the Electoral College, right? Different states have their voting chunks, right? So we talked about it yesterday, like stockholders and that kind of thing. It's a weighted voting system. Different people have different amount of votes depending on population, if it's states, or money, if it's financial investors in the stock market or whatever. So Q is 14. So they're gonna have me redo this problem, part A, part B, part C, changing the Q each time. It's really 3 problems in one, in other words, is what it is. Right? I'm going to do this all this big work for part A with Q14. So let me do that right now. So I'm going to make Q be 14. In fact, let me just write the system. It's 14 for Q, colon, 14, 8, 3, 1. So there's the weighted voting system they want me to do for part A. And then part B, over here, they're going to have me, after I get this all done, they're going to have me change the Q, and then part C is a different Q also. All right, so this is player 1, this is player 2, this is player 3, and this is player 4, and this is the quota, which is the amount it takes to pass anything. Remember how that works? So to pass anything, make any decision, for this, if this is an investment company, for them to make any decision on what to invest in or whatever, it's going to take 14 votes to make a decision. So any thoughts as you first just glance at it?
P1 is a
Yeah, what is P1? Dictator. Right. Correct. P1 has absolute power. Right?
So would that mean P's 1 to 1, I guess?
P's got what we'll find is that player 1 is going to end up having 100% of the power. And if he has 100% of the power, how much power does P2, 3, and 4 have?
So they're all dummies?
Yeah, they're all dummies. Exactly. Now, I'll go through the formalities of showing that. But let me just tell you right now, that's what's going to happen when I start listing the winning coalitions and all the stuff. It's going to end up being that way. This is going to be a weird one. Part B and Part C will be more normal. This is a weird one, right? Because player 1 has enough power to get it done all by himself, right? Player 1 has as many votes as you need to pass anything. So he's a dictator, and therefore everybody else is dummies, right? Let me go through and prove it, though. That is going to be the answer. But let me go through. So remember the method. What I really want to show you how to do, and make sure you're comfortable with, is that method we did last time. Remember what we do first? We list all the winning teams, or it's all called coalitions, whatever you want to call it, all the winning teams. Okay. So first off, what are all the winning teams with 4 players? So you do all the winning teams with 4 players, all the winning teams with 3 players, all the winning teams with 2 players. So if you have 4 players, well, that's everybody. And certainly everybody is a winning team. And then you say, okay, what are all the winning teams with 3 players? Now, how do you form a winning? What do I mean by winning team? How do they win? How do you know they win?
14, right?
Yeah, they got to make 14 or more, right? Because that's what it takes to win, to pass something, for that team to get their way in investing or whatever it is they're trying to decide. So with 3 players, now, how many different 3-player teams are there? When you have 4 people, how many 3-player teams are there?
3. 4.
Well, if you have 4 people total and you're going to form a 3-person team, you got to leave somebody out. Right? That makes sense? Right? If you got 4 and you're going to pick 3, you're going to leave one person out. Well, how many different ways are there to leave one person out? You can leave out the first guy, that'd be a team. You can leave out the second guy, that'd be a team. You can leave out the third guy, that'd be a 3-person team. Or you can leave out the 4th guy, that'd be a 3-person team. Those are all different 3-person teams. So every way you can leave one person out is going to be a different team, isn't it? So there's 4 different teams. You kind of want to know that in advance because it's just easy to make a small mistake when you start listing things. So you want to think in advance, there better be 4 of these or I missed something, right? There's got to be 4 3-person teams. So leave out the first guy 8, 3, 1. Leave out the middle guy, so 14, 3, 1. Leave out the third guy, so what's that? 14, 8, 1. And leave out the fourth guy, 14, 8, 3. So I listed all the ways you can have 3 people on the team. Is that making sense? Now, are those all winning teams?
No.
Yeah, because they don't all make 14, do they? You got to have 14 to win, to get your whatever you're trying to get done. 8, 3, and 1 doesn't make it, so they're out. They shouldn't be there. All the rest are good, though, right? Yeah, all the rest are good.
So would you still add those, or would you just not?
Yeah, no, they're just gonzo. Yeah, because I'm only supposed to be listing the winning teams. So we skipped that one. So only list the win. So I listed them at first just to make sure I was checking everything, but then cross them off because they're not really a winning team on that. Good so far. And now we got to do all the 2-player winning. So at first, I'm just going to list all the 2-player teams. I'm not even going to think if they're winning or losing. I'm just going to list them all, and then I'll go back and say, hey, was that really a winner or was that not? So remember the system. One of the skills that you have to obtain that this chapter is requiring is the ability to be systematic in your listing. That's a valuable skill in lots of jobs, is being organized systematically. So how can I list? Can you list all the 2-player teams with a system rather than randomly? Because if you just start kind of writing them down randomly, you're not going to be sure you've got them all. And if you just miss one, it's over, right? You're not going to get it. So you've got to get them all, and the system will give you that. So how do you do it? Well, I said you just start with the first one, 14, 8. Do the second, and then 14, 3, and then 14, 1.
That's really all you have to do.
Yeah, you're right. But I'll keep on going, pretending I don't know that, just to be systematic. But so far so good. I start with the first one, and I just go second guy, third guy, fourth guy. Just go right down the line. Okay, and then start with the second guy, the 8, and go 8, and then just go down, just like we were doing the round robin tournament the other day, right? Done with the second. Now start with the third guy, so that would be 3, 1. That's got to be all of them. Remember how it goes down by 1 every time? 3 of them, 2 of them, 1 of them. Is that good? See how I used a system to make sure I didn't miss any? You start with the first, second, third, fourth, then start with the second. Just keep going down every time. Okay, now, we're really supposed to only be listing the winning ones. That's all the 2-player teams, but are they really all winners? Are they all making 14? No, none of these are making 14. Are they? 3, 1, 8, 1, 8, 3. None of those make 14. Those are out. They're not winning teams. I'm only supposed to be listing all the winning teams. Good? So I've got all the winning teams. Well, actually, technically, there is a 1-player winning team also. Just 14. Yeah. Because he's a dictator. That's not usual. Anyway, so there's all the winning teams, including 14 alone. Those are all the winning teams. That's what you're supposed to do first off, right? When you do this Bahnhof power thing, you're trying to find out what's the real power in this system. We already know the answer, but I'm just going through the formalities. There it is. Now, which ones of these are critical? This is the hardest part, and the most critical part, is finding who's critical. It really is. Now, what does it mean to be critical? I told you the story to help you remember, right? Anthony on my son's baseball team, he was critical. If he came, we won. If he didn't come, we lost. Right? Didn't matter about the other 8 guys in the field. If Anthony was on the mound and Anthony at the plate, we won. Baseball's kind of like that, huh? One guy can do a lot of stuff. So that's how this is. So you want to find out who's critical, who makes the win-loss difference. Does the 14 in the 4-player team? Now they're a winning team right now, meaning if you add them up, they're 14 or more. But if 14 drops out, says, I'm not with you anymore, Anthony doesn't come to the game, do they win without him? No, they lose.
So is the dictator always critical?
Yeah. So he's critical there. If he doesn't show up, 8, 3, and 1, what's that? 12? That's up to 12. So that's not enough. They don't have enough to win without him. Just like when Anthony didn't show up. So how about the 8? Now if the 8 doesn't show up, if the 8 says, I'm not coming, They got the 14. They don't need any of these guys. And if we keep on going, what you'll find is 14 is the only guy ever critical on any team. He always makes the difference. If he's there, they win. If he's not, no way do they win. They can't make 14 without him. So, you see, all we have is 14 being circled. That's why he has 100% of the power. Remember I gave you the answer already? I said, so the final answer, oops, let me get a little bigger there. So the final answer in the end, we're ready for the final answer now. It's player 1, which I already gave you. Player 2, player 3, player 4. Player 1 has 100% of the power. Because he's got 100% of the critical times. That's what power is. When you make the difference, right? That's what real power is when you swing the vote from not making it to making it. And that's only the 14. Nobody else ever swings the vote here. Everybody else is 0. 0, 0. So that's as we already knew. But we see it now. Why is that? Because only this guy's circled. Now remember, the one we did end of yesterday, we had other people being circled, which we're going to do when we do part B here in just a second. But normally you have other people being circled, and then remember how you do the percentage? You just take the total number of times people were circled, whatever it is, 10, 12, 15. That's the denominator of the fraction. And then the top is how many for you. Like I was 10 out of 15 of the circled times. Then that's your power, right? That's your percentage of the power. All right. So let me go on to part B. It's more of a normal one. That was a weird one. We good? You guys got that down good enough? Again, this is on. I'm going too fast. It's on YouTube. So, okay. Let's do part B now. It'll be more normal. We'll make this 15. So I'll go, okay. The quota this time. Same 4 players, but this time the quota is 15 instead of 14. I'm doing part B. So this is part B. Part B where the quota is 15. They changed it from 14 up to 15. So that means that first player is no longer a dictator. He can't get it done himself. So he's not going to have 100% of the power. He's not a dictator. He needs someone else to join his team to pass things. That good? All right, let's go through it again. Let's list all the winning coalitions. That's where you start, right? The winning teams. Wait, I just spelled that right. Coalitions. So, first off, the 4 player. Well, that's just all 4 of them. No big deal there. All right, list out. So on your paper there, list out the 3 player teams. List them all the 3 player teams. Remember how to do that? You just leave one guy out, right? So you leave out the front guy, leave out the second guy, leave out the third guy, leave out the fourth guy. Should be 4 different 3 player teams. And then keep the ones that are winners. The ones that can make 15 or more. Right? That's the winning mark in this one.
If like a 3-1, like 1 of 3, they can do all 3, so but they just take out 1, are they all winners?
Say that one more time.
So say if they have like a group of 3, but they can all make 14, but all you have to do is take out 1, are they still winners?
They're all critical.
Yes.
They're a winning team,
Yes.
and they're all critical values.
So that means you circle all.
That's right. Yeah, most of the 3-player teams will probably be all critical, I think. No, that's not true, is it? No. All right, anyway, so how do you list all the 3-player teams? You just leave somebody out, right? Every way that you can leave somebody out, you've made a 3-player team. So if I leave out the 14, I've got 8, 3, 1. Or if I leave out the second guy, the 8, I've got 14, 3, 1. Or if I leave out the third guy, the 3, I've got 14, 8, 1. Or if I leave out the fourth guy, the 1, I've got 4. Here, I'll put it down here. 14, 8, 3. So first off, I'm not sure those are all winners, but those are the 4 different 3-player teams. Good so far? Can you do that with a system like that so you don't accidentally miss anybody? Now, which of those are the winning teams? Well, to win, they got to be 15. Yeah, so not this. Well, I didn't mean to erase it, but what was it? 8, 3, 1. Yeah, not this one, but the other three, huh? Yeah, the other three are all winning teams. Is that good? Now let's go on to the two-player teams. So see, can you use the same system we used last time to form all the two-player teams, right? The round-robin thing, right? See if you can get them all. And then keep the ones that are winners. Keep all the ones that are winners. All right, so so start with 14. Remember how it works? You start with 14, you go to the second guy, the third guy, the last guy. Like that. And then you start with the 8 and you go down. You just keep going down the line. And then lastly, 3 and 1. Is that good? Remember how that works? That's all the teams, but they're certainly not all winners, are they? So what do they got to do to be a winner? Got to make the quota. 15. They got to make 15. So 3 and 1, that only makes 4. That doesn't even come close to 15. So cross it off. 8 and 1 makes 9. That's not 15. 8 and 3 is 11. That's not 15. But 14 and 1, that makes 15. 14 and 3 is more than 15. 14 and 8 is more than 15. So those three are winning teams, aren't they? Those are keepers. They're winners. So lastly, there's not a one-player winning team here because this is not a dictatorship. So there it is. That's all the winning teams. Now, the hard part. We have to go through. This is where you got to be really careful. Got to go through player by player by player to find out who is critical, who makes the difference, or who doesn't. You're going to circle all the ones that are critical. Meaning, what does critical mean? So let me make sure we're really, really clear on that. Critical means if you drop out, the team loses. Right? If you drop out, the team loses. Like I told you about Anthony and my son's Little League baseball team, because he had 3 different teams he was playing on. Sometimes he didn't show up. We'd always watch and wait and see if he was coming. We'd lose without him. So, critical means if you don't show up, they lose. So, let's go up here and look at the 4-player. If that 14 right there doesn't show up, does that team lose?
Yes.
Yeah, they only have 12. 8 and 3 is 11, and 1 more is 12. They only have 12 without him. So he's critical. If he doesn't show up, they lose. He's critical. That's what it means to be critical, right? You're only critical if you're making them win. If you don't show up and they lose, you were critical. Okay, next one. How about the 8? If the 8 doesn't show up, and all they have is the 14, the 3, and the 1, do they lose because the 8 didn't show up? No, they still win. They don't lose. So he's not critical.
I'm assuming the 1 is the only critical one.
Well, if 8's not critical, how could 1 be?
So like you said, anything below it is.
Yeah, no way. I don't even need to look further. I mean, I'll do the 1 if you want as a formality. Suppose the 1 doesn't show up. Do they lose?
No.
No, they totally win. So 1's not critical. Yeah, once you've got somebody not critical, then everybody below that can't be critical either, right? You couldn't have 8 not being critical and somehow 1 is. That couldn't be. 1's not as good as 8, right? So it can't be. Good there. So in the first one, it's only the 14. Let's go down to the 3-player teams. How about down here now? This is a winning team. These are all the winning teams. This is a winning team. 14. If he doesn't show up, do they lose?
Yep.
Yeah, they only got 3 and 1. They only got 4. They're going to lose. So 14's critical on that team. You see what we're doing? We're looking at every possible scenario, figuring out when people will make a critical difference. How about the 3 now? What if the 3 doesn't show up on that team? Do they win without him?
Yep.
Or I should say, do they lose? This is the real question. Yeah. If he doesn't show up, do they lose? No, they still win, 14 and 1. So he's not critical. He can not show up, they're still going to win. So 3's not critical, so 1 is not either, right? So only 14 is critical there. Let's go down to the next one. 14, this next team. So as soon as I find somebody not critical, I'm done. 14, if he doesn't show up, do they lose? Yep, they lose without him. He's critical. How about if the 8 doesn't show up, do they lose? No, they got 14 and 1. They got 15. They're good. So 8's not critical, so we're done with that team. Next one, 14. If he doesn't show up, do they lose? Yep, they only got 8 and 3, and they only got 11. They need 15. They lose. If the 8 doesn't show up, do they lose? 14 and 3? No, they win. That's enough to win. 8's not critical. Neither is anybody else. So far, all we've circled is 14. But that's about to change. Let's go to the 2-player teams now. Now coming over to the 2-player teams. If 14 doesn't show up, there's a winning team right now, 22. That's more than 15 or more. 14 doesn't show up. Obviously, they lose. They've only got 8. They're going to lose. How about the 8? If the 8 doesn't show up?
Both critical.
Both critical. If the 8 doesn't show up, they lose also. That 14 needs the 8, if it's just 2 of them. And so the 8 is also critical in that role, isn't he? If the 8 doesn't show up, they lose. 14 loses without. So down here, 14 is critical, again, because if 14 doesn't show up, they lose. But also the 3, If the 3 doesn't show up, the 14 loses without and doesn't have 15. Next one, both are critical again, If either one doesn't show up, they're going to lose. They're both critical. And that's it. That's all the times. So how many times was somebody critical? How many times were things circled up there? Just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times I circled things up there. You seeing that? 10 critical times circled. 10 times people were critical. If they weren't there, the team would lose. 10 times people were critical. So that's going to be the denominator for the power statements, right? Player 1, player 2, player 3, player 4. It's going to be something over 10, something over 10, something over 10, something over 10. Because it's out of 10. It's whatever portion of the power each person has over 10. There's 10 times that real power was exercised. 10 times when people were critical. Is that making sense? How many times did player 1, the 14, player 1, how many times did he exercise
7.
power? 1, 2, 3, 4, 5, 6, 7. Yeah, 7.
Tally marks are a good way to keep track too.
Tally, yeah, tally them. Mm-hmm. So player 1, 7 of the 10 times when power was exercised, 7 of those, it was player 1. So he has 70% of the power, doesn't he? Right? Out of all the times power could be exercised in all possible scenarios for this team and how they vote, for this group and how they vote, 7 of the 10 times player 1 had the power. If you divide that in your calculator, you get 70%, right? Or 0.70. I don't care, decimal fraction, percentage, whatever. It's just multiple choice on the test. Just grab the one that's the same. I don't even know what format. We'll look at it tomorrow when we do the practice exam. And you can use your calculators during the test, change back and forth. Fraction, decimal, percentage, whatever. The next one, I guess Math Excel wants fractions. So they want 7 out of 10. Player 2. Player 2 is the 8, right? This is player 1, player 2, right? Player 2 is the 8. How many times did 8 get circled up there?
Once.
And just right here. Just the one time. He's 1 out of 10. Player 3 is 1 out of 10. Player 4 is 1 out of 10. They each have 10% of the power. Don't they? If you wanted a percentage. They each end up with 10% of the power. So there's the power structure on part B. Player 1 is no longer a dictator, but still has a lot of power. 70% of the power, and the other 3 players have 10%. See how we're getting that number? That's the percentage of the time when real power is exercised that it'll be them exercising it in all possible scenarios. See how that describes real power? See how we're using math to describe real world? So if this was like a stockholders company, and you had stock, and you got number of votes based on your stock, and they made 15 to pass anything, you know, you might look at your number. The 8 might look at the 14 and go, well, I got more than half, you know, but you don't got more than half the power. He's only got 10%. He's got 70. So things aren't always as they seem unless you do some math to play it out. So the math would tell the 8 guy, you better buy some more stock. Or just go down to 1, because you got the same power as the guy that's only got 1. Why are you holding on to 8? You don't have any more power than the guy that has 1. You better go higher or go lower. It's a waste to be in the middle, isn't it, in this scenario? So the math informs society, right? That's the purpose of this course, is how can we use math to help us think about decisions in society. So this is helping us think about power structures and how much power people and organizations and states really have. Does that make sense on that? You know where they do this, for example, the UN, the United Nations Voting Council, it's got some complex structure. There's like, you know, the United Nations, whenever they decide to do something in the world, United Nations, who that is really, is there's 5 big countries, us, Russia, we're the United States, us, Russia, China, who else is it? Is it France and England? I don't know. You can look it up. Japan, I don't know. France and England, I think. But anyway, it's 5 big countries, and then they have littler countries that rotate on every, I forget, you type it into Google and you'd see it, but it's a complex structure, and so you can calculate the actual percentage of the power the different countries have. In fact, that's something they do. The advisors have done all that. They want to know, what kind of power do we really have in this voting scenario? So real life, governments, businesses, they want to know, what kind of power do we really have? And this math helps us inform that. All right, anyway, so the power you guys care about mainly is the power to do well in this next exam, I know. So let's just do one more of these and make sure you can do this on the next exam. Let's do 22 questions on this one, yeah.
When I put the fractions in, it gave me an incorrect answer.
Did it? Did you have the same stuff we had this last
Well,
time?
I was kind of following along with you, but I was also doing the work. and
14,
I got the
7. Yeah, your numbers are a little different, so I could glance at it later, but it might just be a different answer on that one. Because your numbers are different than mine.
Oh wait, we were working on the second part, that's why.
Oh, yeah, you're right.
I had looked at it.
You're totally right. You're totally right, yeah. All right, let's go on to part C.
10 out of 10, I'm assuming?
Exactly, or just 1. You can just put a 1 there.
Oh yeah.
10 out of 10 reduces to be 1.
And then just go for the rest.
Yeah.
Didn't you say like all the methods are unfair though?
Okay, that was chapter 1. I know these things get confusing. Yeah, that was chapter 1. That was the different ways of voting. Now we're doing, of course, they're both kind of voting. I know it's confusing. Then now it's power voting. That was voting. Yeah, the 4 different ways of voting. They were all unfair. You're right. They're all. That's what Arrow's and possibility theorem said. You're right on that. All right, let's do. Am I on the right screen? Yeah. Okay, let's do part C now, which is Q22. So in other words, we're looking at the quota being 20. This is part C now. Part C, the 22 in the front, and then the 14, 8, 3, 1. All right, so give it a try. Let's try one more time on this. Hopefully it's getting a little more comfortable.
There we go. Fix it.
You like that better, huh? So do the same thing. List out the 4, what's it called? 4 players. 4 players. 4 players. This is winning coalitions. Oops. Winning coalition. So 4 players. So go on to 3 players. See if you can list it aloud. I'll throw it all on the board in a minute, but see if you can get that. Let me know if you want help. I'll wander around. Feel free to prepare those around you.
This was just the last one. My bad. For some reason, I didn't know which one.
What's that?
Last one.
What was the quota? is not critical. 10 is critical. Just the 10 is, just the 10. No, yes, just the 10, so that should go. Yeah, yeah. Four sources, yeah.
Thank you.
Yeah.
What's that?
Oh, for the, okay. Just after class, I can, if you have a minute, I can try it out. Do you? Do you? Yeah, well, I can look for success. This wasn't working, huh? Yeah, I don't know, I don't know. Some kind of technical thing, yeah.
You must find the critical and the finish.
Yeah, right, try to do that same kind of stuff. Okay, so 4 players. Yeah, so I'll list out the 4 players. 14, 8, 3, 1. And then 3 players. Players. So 3 players, remember you leave somebody out, right? So leave out the 14. Leave out the 8. Leave out the 3. Leave out the 1. But we only want winning teams. So they got to make 22. So that's no good. That's no good. The other 2 are good. So you getting that right? So you only got 2 winning 3-player teams, right? They got to be winning. They got to make, remember our quota is 22. So they got to make 22 here for part C. See if you can get that. There's you try to call that this afternoon, I called him several times, call him up, you know, and just say, hey, logging in is not working, so I won't drop you. So give him a call and try that.
So are you
You read online, okay?
Yeah.
Good. Yeah.
So there were 3 players.
All right, guys, doing okay on this? Let's see. So the two player. So the 2-player teams. You know, I'm not going to waste my time. There's only one winning, isn't there? Only 14-8, because you got to make 22. So I'm not going to list them all and cross them all out. It's just 14 and 8. Huh? That's the only 2-player team that makes 22. Good there. Okay, so there's all the winning teams. Let's go back now and circle who's critical. That's the part I've noticed is it can be hard for students to get real clear on. Is that making sense? What it means to be critical again is if you're not there, they lose. Just keep asking yourself that question. If they're not there, critical again, critical means if you are not there, the team loses. That's what it means to be critical. If you are not there, the team loses. So let's try it out. If 14, I start with a 4-player team. If 14's not there, does 8-3-1 lose? Yeah, they're trying to make 22 on this one, huh? So 8-3-1 is not enough, they'll lose. So 14's critical. How about if the 8 isn't there? If the 8 doesn't show up at the game, can 14-3-1, do they lose?
Yep.
Yeah, because that's not enough. That's 17-18. That's only 18. That's not 22. So 8's critical also. How about if 3 doesn't show up? 14 and 8 is 22. No, they already have enough. That's 22. If 3 doesn't show up, they still win. So 3 and therefore anything below that, 1, are not critical on that team. Only 14 and 8 are critical. Must be there. Right? All right, how about come down to the 3-player team? 14. If 14 doesn't show up, do 8 and 1 lose without him? Yeah, they lose. 14's critical. If 8 doesn't show up, does 14 and 1 lose without him? Yep, so 8's critical. If 1 doesn't show up, do 14 and 8 lose? No, 14 and 8 have 22. So they don't need the 1. The 1's not critical. Coming down to the next one, if 14 doesn't show up, 8 and 3 lose, yes. If 8 doesn't show up, do 14 and 3 lose? Yes. If 3 doesn't show up, do 14 and 8 lose? No, they win. They have 22. That's exactly what they need. They're okay. 3's not critical. Up here for the 2-player team, 14 and 8 are both critical, huh? If either one of them doesn't show up, they don't have 22. They're both critical. So there we are. We circled all the critical times. How many critical moments were there?
5 for 5-player win, and 5 for player 2.
Yeah, just counting all together. 1, 2, 3, 4, 5, 6, 7, 8. Looks like 8. 8 total. Yeah, 4 and 4. 8 total. So player 1, player 2. It's going to be out of 8. There's 8 total. At least we'll reduce the fraction afterwards. But at first, it's out of 8. 4 times player 1 was critical. 4 out of 8 reduces to be a half. And 4 out of 8 player 2 reduces to be a half. So player 3 and player 4 were never critical. So they're both 0, aren't they? They're both 0.
How come we did 100 and did 8 this time? Oh, 8.
Yeah, only 8 this time. Last time there were whatever there was. 10. Yeah, 10. Is that making sense up there? What we did that? So when the quota changes, even though the players haven't changed, it changes the power spread, doesn't it? Quite a bit, huh? Remember last time, player 2 only had 10% of the power. This time he's got 50%. Okay, questions on doing that? You feel like you can do that kind of thing? Bahnhof power? Any questions before I move on? So that was a big, difficult. Yeah, so how about that? I'll do it quick. I'm not slow. I won't explain like every little detail. I'll kind of do it quick, and then you'll have it on the YouTube if you want to see it. So, all right, I'll do part A here. So I'm doing number 1, part A of number 1. It's question 1 now. I kind of went backwards. I started with number 2 and back to number 1 now. So here it is. It's 24, 12, 10, 8, 4, 2. It's kind of a pain because there's 5 players. See how there's 5 players? Player 1, player 2, player 3.
With 5 players.
Yeah, but that makes it a lot harder because there's just a lot more different groupings.
It'll be like 5,
Yeah.
4, 3, 2, and 1.
Yeah, so start with a 5-player team. That would be everybody. 12, 10, 8, 4, 2. Okay, go to the 4-player team. Now, how many, here comes the quiz question, see if you're getting the concept. How many 4-player teams? You have 5 originally, so how many 4-player teams will there be? There'll be 5. Well, I don't know how many will be winning, but there'll be 5 total, right? Because you can leave each of the 5 guys out, right? One at a time. So I can leave out the 12, and we'll have 10, 8, 4, 2. Or I can leave out the 10, and we'll have all the other ones. Or I can leave out the 3rd guy and have everybody else. or I can leave out the fourth guy. Have everybody, or I can leave out the fifth guy, the last guy. Okay, so there they all are. See how you got to be systematic so you don't miss even just one. Even if you miss just one, it'll mess you up. That's why the system matters. Okay, now are those all winners? What do you got?
So.
What do you got to have a winner? 24. So we need 24. That's my quota. That's the winning mark. Do they all make 24? Yeah, I think they do. Yeah, they all make 24. Or more. Yeah, they're all winners. They're all winners. That's a pain. That means you got to go through all of those, circling who's critical. It's going to be a pain.
That's where tally marks come
Yeah, that can be. Okay, so now, 3-player. Now, yeah, this is a real pain. How do we find all the 3-player teams? It's not easy. You got to be careful. What do we have to have? 24. So I'm going to start with a 12. 12, 10, 8. That makes 24, doesn't it? And then 12, 10, 4. And then 12, 10, 2. Do you see do you see the system I'm using to make sure I don't miss any? Let me pause there for a second. Are y'all seeing what I'm doing there? I'm starting with 12, 10. I'm just saying, all right, I need to pick a 3-player team. So I'm going to start with 12, 10 and throw on it 8, 4, or 2. Is that good for starters? That's my 12, 10 teams. And then I'll go down by 1. I'll form some 12, 8 teams. Right? So I can start 12, 8. And I can go down from there. Finish with 4, finish with 2. See my system? Start with 12, 10. Go to 12, 8. Now do 12, 4. Do you see how I'm going down the line? Just like we did for the... So see, the first two come from like the round robin tournament idea, right? Start with the 12, 12, 10. 12, 8, 12, 4.
You don't really need to do the twos, right? Just because they probably won't add up anyways.
You're right. You're right. If you want to do that, that's fine. I'm just going to kind of think about one thing at a time. But if you can do that, great. You're right. There's nothing that's not going to really last. It's going to be crossed out in a minute. That's true. So, all right. So I got all the ones starting with 12. Now I got to do all the ones starting with 10. You see what I mean? Those are all the ways you can start with 12. 12, 10, 12, 8, 12, 4. Now I got to do all the ones started. This is tedious. See what I mean? It's not a little bit harder. It's a fair bit harder to be exact and not miss even one. Now I got to do all the ones starting with 10. 10, 8, 10, 4, 10, 2, right? So I'll go 10, 8. But if you start 10, 8, there's 2 ways to finish. With a 4 or with a 2. Because I'm doing the 3-player teams right now. It's a funny looking 8. See, those are the 2 10, 8 teams. 10, 8, 4, 10, 8, 2. And finally, 10, 4, 2. Yeah, a lot of these aren't winners. Yeah, we're pretty done at this. None of the rest are going to be winners, but there's only one more team. The only team left. So I've started with 12, I've started with 10, now I start with 8. Well, if you start with 8 and you're only going down, that's all you can do, 8, 4, 2. So, in fact, I'll just squeeze that in right here, 8, 4, 2, because we're just going to cross it off anyway. It's not a winning team. That is all the 3-player teams, and a lot of those are not winners. 8, 4, 2 is not a winner. What's it got to make 22? That's not a winner. That's not a winner. They don't make 22. Right? Oh, the rest do, don't they? No, this one doesn't. Oh, that does. No, it's got to make 24. I said the wrong number. It's got to make 24. None of these are winners. There, the top 4 are winners. So I crossed most of those off. Only the top 4 are actually winners. Make 24. You tracking with me? This is kind of painful, huh? And we haven't done the 2-player teams yet. And if we make one mistake, we lose the ball game. So you got to be flawless in your thinking.
I can tell from all the combinations that there are gonna be.
Oh yeah. Oh, this is easy. Yeah. Yeah. What's the strongest two-player? Good think. I didn't even think about that. What's the strongest two-player team?
12 and 10.
Yeah, the 12 and 10. They're the best, strongest. Do they make it?
No.
Then nobody's making it. Right? 12 and 10 make 22. They don't make 24. Then there's no way any two-player team is going to be a winner.
So
That's
you would say
nice.
that would be a good shortcut.
That is really good. So we're done. We got all good. I was hoping something like that would happen. Good. So we can skip the rest.
You're about to write it all down?
What's that?
You're gonna write it all down?
I was gonna. That would have been a bad plan.
What?
All right. So we got all the winners up there now. Now we have to go back and circle who's critical on each team. Meaning, if they don't come, team loses, right? So it means be critical. So how about this 12 here? Back to the 5-player team. If the 12 doesn't come, do they lose? 18, 12, oh no, 24, they win. No, I better not circle him. He's not critical. If the 12 doesn't, I'm not used to that. If the 12 doesn't come, they still win without him. Right? They have 24 without him. So if he's not critical, nobody's critical on that first team.
Because they're all lower, right?
Because they're all lower. Yeah. Does that make sense? See why 12's not critical? If 12 doesn't come, the other one is still out up to 24. So he's not critical, and if 12's not critical, lower guys can't be critical either. So nobody's critical on the 5-player team. Anybody could not show up and the team's still going to win. Let's go down to 4-player. Okay, so if the 10 doesn't show up, here, let me use a different color here. If the 10 doesn't show up, do they lose? I think so. All right, because if 10 doesn't show up, 8, 4, and 2, they don't make 24 anymore, not even close. If 8 doesn't show up, do they lose? Just 8. 10, 4, and 2 they don't make 22. If 4 doesn't show up, do they lose? Yeah, they've only got 20. If 2 doesn't show up, do they lose? Yeah, they've only got 22. They need, without the 2, they need the 24. So they're all critical, even the 2 on that team. See how that works? Even if the 2 doesn't show up, they lose. They've only got 22 without him. Right? Next team. If the 12 doesn't show up, yeah, they lose. So I'm just going to do this quick now. If the 8 doesn't show up, yeah, they lose. If the 4 doesn't show up, they lose. If the 2 doesn't show up, no, he's not critical. If the 2 does not show up, they've got 12 and 12. They got 24. They got enough. So 2's not critical there. So you can just circle these. You can check it out later. I'm glad to help you if you want to grab me later. What? 4, not critical, right? 12, yeah, not critical. And then 12, 10, 8 doesn't show up, not critical. 12 and 10. Yeah, not critical, right? Yeah. Okay, and now for the 3-player teams, they're like gonna all be critical, aren't they? Yeah, on the 3-player team, those are all critical. Even if the 8 doesn't show up, they don't win. Yeah, they're all critical. On the 3-player teams, even the 2ers are critical. Yeah, everybody's critical on the 3-player teams. If any one of them doesn't show up, they lose. They fall below 24. All right, there we go. Circle them all. All the circlings have been done. So, how many critical times were there? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 22, 23, 25. 25? Did you guys get that? Anybody else doing this problem? But me? 25. So they're all going to be 25 denominator. Right, you with me? They're all at 25. There's 25 critical times unless I miscounted. 4, 7, 8, 9, 10, 13, 13, and 12. 25, yeah, 25. Okay, I counted twice. 25. All right, so how many are player 1?
8.
1, 2, 3, 4, 5. Yeah, 8. Looks like 8. 8 out of 25. That's 32%. Player 2. 1, 2, 3, 4, 5, 6, 7. Yeah, looks like 7. How many are player 3, which is the 4, or the 8? The 8. 1, 2, 3, 4. 4. How many are the 4? 1, 2, 3, 4. And then how many are the 2? 1, 2. It's always good to double check when you feel like you have it. Add them up. They better add up to 1. 25 over 25, in other words, right? They better add up to 25 over 25. Does it? 15, 19, 23, 20. Yep, it does 25. So I've probably got it. Probably not messed up. So there we go. See, that's pretty painful, huh? 5 players is pretty tough. When they give you a hint on part B, and they say, hey, on part B, all you're going to change is the quota by 1. You're just going to change the quota by 1 up to 25. So you might be able to use this same setup we've got, and then just make a few minor changes for part B. Is that good? Is that okay? Everybody got that copy down?
You want those percentages?
It's okay. Yeah, the math Excel just wants the fractions, so it's good enough. All well? Okay, it'll be on the YouTube later if you okay. So here we go. So law firm is run by 4 partners. Each partner has 1 vote. Decisions are made by majority rule. But if there's a 2-2 tie, the coalition with the senior partner wins. List all the winning coalitions and the critical players. They give me some multiple choice options there. All right, so, and they're underlining instead of circling. All right, so what are we even talking about? So, got this law office, right? We got four partners in the law office. They make decisions, majority rules. Makes sense? If 3 people want to do something and 1 doesn't, they do it, right? Majority rules. But what do they do when it's a 2-2 tie? What do they do when it's a 2-2 tie? How do they decide what to do? Well, whichever group has the senior partner, D, right? D, yeah, D, they win. So that's the tie-breaking rule. Whoever, if it's a 2-2 tie, whoever has D wins. Otherwise, it's just majority. 3-1, 4-0, it's majority. Unless it's a tie, the tiebreaker rule is D, D's team wins. He's the senior partner. Okay, so let's go through it. Let's list the winning teams, the winning coalitions. They call them. I can't spell that. Coalitions. So I'll just say teams. The winning teams. So what are they? So first off, we have the 4-player. Remember, you're supposed to list all the 4-player winning teams, the 3-player, the 2-player. So 4-player. Well, that would be all 4 of them, A, B, C, D, right? Obviously, that's a winning team. If all 4 of them want to do something, then they'll do it. How about 3-player? Are there some 3-player winning teams? Well, can you list every 3-player team? Remember how to list them all. Just leave somebody out each time, right?
You know, like ABD.
Right. So I could like leave out, I'll just leave out A, B, C, D. I'll leave out B, A, C, D. I'll leave out C, A, B, D. And I'll leave out D, A, B, C. Good? Those are all the 3-player teams? Do those all win? Is it tricky on this? This one, there's no numbers, right? There's no numbers to add up. It's just you got to follow a rule. So they're giving a rule, a verbal written rule, instead of a number rule. What's the verbal rule? Majority wins. And in the case of a tie,
No B.
whoever has the D.
Oh, B.
So, if three players,
So the only one that doesn't win would be ABC, right? Because they don't have D.
these all win, because they're all majority. They're all three people wanting to do something.
Okay.
Oh, yeah.
So we only do the D thing in the case of a tie. 2-2 tie. That's only the tiebreaker rule.
Sure.
Does that make sense? If three people all want to do a certain thing with the law firm, they do it, because they're a majority. Right? That's the rule, majority. So all these are winning teams, aren't they? The D thing is only in the case of a tie. If it's a 2-2 tie, so nobody has a majority, how do you know what to do? Then whoever has the D, the senior partner, they win. That's only the tiebreaker rule, though. Does that make sense? So majority always wins. That's the rule they said, right? Run by 4 partners, da-da-da. Decisions are made by majority rule. More than half, 3 people. Okay, so now let's list all the 2-player teams. What are the 2-player teams? Well, you know how to do it, right? You start with A, it's like the round robin. A, B, A, C, A, D. Then you start with B. B, C, B, D, and then you start with C. C, D. So there they are. There's all the 2-player teams. But are those all winners? I feel like I'm losing you. I feel like I'm doing the Charlie Brown teacher up here. The wah-wah-wah. I'm looking out at confusion. Am I making any sense? I know it's a shift all of a sudden. The rule thing.
Now the ones with B.
How do you know if a team wins? Like if they get their way, if they get to do whatever the...
Majority, or if they have.
Yeah, it's majority, or in the case of a 2-2 tie, it's whoever has D. Right? So then when I put A, B, is it making sense? When I put A, B in parentheses, what I'm saying is A and B get together, decide they want to do something. Do they get their way? Do they win?
Yes.
No.
Well, if A and B are deciding to do something, that means the other 2 are not.
But they have A.
So it's a 2-2 split. You're supposed to have
No D.
D. D's the senior partner. I know it's different on different versions, huh? Yeah, so the one I have anyway, you're supposed to have D. So all these 2-player teams are a 2-2 tie, aren't they? Right? They all are 2 people want to do something. The C and D are not listed, so they must not want to do it. At least in my first parenthesis here. So in a case of a 2-2 tie, how do you know if they win? If they have D. So these guys do not have D, do not have D. Those guys do not have D. So those ones that did not have D, I crossed off, because if you only have 2 people wanting to do something, they don't win unless they have D among them. Make sense?
Mine says coalition with B and the junior partner loses, so I'm assuming if it has B, you just cross it out.
Yeah, right. If it's a 2-player team.
Okay. Yeah.
Only for the 2-player case. Because the 3 players are still automatically majority.
Majority.
Yeah, that's right. Yeah, sometimes. Yeah, good point. Sometimes I always put this one on the test. No secrets with me. There's one like this on the test. I mean, it'll be changed. It might say like what you were saying. It might be just like this. I don't even remember. But it might shift it. It's really kind of random. I just make up my tests off the publisher's test bank. So I just go in there and I say, give me a coalition problem with a rules by a word. Give me one of those. And give me one of the 4-player with numbers. And give me one of that, and it just randoms the particular. So there'll be one that's based on a verbal rule. And so here, let me give you for instance. They might change it, and it might say, in the case of a tie, but it's always majority rule, but in the case of a tie, whoever has, let's say, A, is the junior partner, the newest partner, loses. They can say that. And whoever has A, the other 3 partners are older, whoever has A, automatic loser. So do you see how what it would change here? Is that making sense? You would still, all the 3-player, the 4 and the 3 are automatic winners still. No change there, because they're a majority. But when it comes to the 2-player things, whoever has A would then be crossed off, because they're losers. Right? Because that's what the rule said. But our rule today, in this problem, said whoever has D is a winner on the 2-player team. So we just kept those. Is that good? Is that making sense? All right, let's go. Now let's circle who is critical. Remember, what does it mean to be critical again?
Majority or.
If you are out, if you are out, the team loses. Right? The team loses without you. You're critical. So let's go. In the first four, start with the 4-player team. If A's out, and A says, I don't like that idea anymore. And it's just B, C, D. Do they lose? No, they have a majority still. They still get their way. So A's not critical. In fact, nobody's critical up here. Right? Even D. If D says no, A, B, C still have a majority. Nobody's critical. Right? Critical means if you're out, team loses. Team loses without you. Like Anthony. Okay. 3 players.
I would say the ones without D, right?
So let's take a look at 3 players. So if B says, I'm out, does the team lose without him? C and D would be the only ones in favor. That's only 2 people. That means it's a 2-2 tie. And how do you know who wins in a 2-2 tie? Whoever has D. Well, they would have D. They still win without him. He's not critical. And neither is C. B and C are going to be the same. But D, what if D drops out? If D drops out, does the team lose without him? Yeah, because then they only have 2 players, which is a 2-2 tie, and they don't have D. So they lose without him. So D alone is critical there. Right? Only D is absolutely critical on that 3-player team. Because if D drops out, they've only got B, C, and they're going to lose because that would be a 2-2 tie, and the B, C team would not have D, which is what it said. The team with D wins. They don't have D, they would lose. So D's critical. They'll lose without him. Right?
What would you say about the ones with junior partners? You know, one I was talking about?
For a 3?
Yeah.
So if you had a 3, and who's the junior partner?
Partner B.
So if you had A, B, C, you lose 2-2 with the junior partner. So is A critical? Well, would B, C lose without him? Yeah. Right? Because whoever has B loses in a 2-2 tie. So A is critical. C is going to be the same because A and C are playing the same role.
So it's like the complete opposite.
But what about B? Yeah, it is. What if B dropped out? Would AC lose? No, they would win because they have 2 and they don't have the junior. So he's not critical. So it'd be the opposite. Yep. Yeah, so, and then you just keep going like this. So D is going to be critical on all these 3-player teams. Right? Because if D drops out, the other 2 guys don't have enough to get it done. You with me? We okay? It's making sense? Right? If D drops out, then there's only 2 people left. And how do you decide when there's only 2? If you've got D on your 2-player team, you win. If you don't have D on your 2-player team, you lose. Right? So if D drops out and they only have 2 players, A, B, they're going to lose. Because there are only 2 and they don't have D. So D's critical. If he doesn't show up, like when Anthony didn't come, they lose. So he's critical. Right? How about A, B, C? Is A critical? If A doesn't show up, do B and C lose?
They all are.
B and C lose because they've only got 2 and they don't have D. So they lose. So A is critical. And whatever's true of A is going to be true of the other partners of the same rank. Right? A, B, and C are the same rank. They're all not the senior partner. Right? You know what I'm saying on that? So whatever you find to be the case for A, B, or C is always the case for all the others. Because they're the same rank. Aren't they? Only D is different. Right? In this problem. So they're all critical. If any one of them doesn't come, they lose. All right, how about in the 2-player teams? The 2-player teams, everybody's critical, right? If you're winning as a 2-player team and one of you doesn't come, well, then you've only got one person. You're not going to win. So they're critical. They're all critical, right? If you only have a 2-player team, anybody doesn't show up, they lose. They're all critical on the 2-player team, right? That making sense? Is that good? All right, so we got them all. How many critical times were there? Critical times. So did you count them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? 12 critical times. So there's 12 critical times. So player 1. Well, it's just A, B, C, D, isn't it? So A, B, C, and D. And the answers for A, B, and C had better be equal because they're the same rank, right? D is only going to be different. So how many times was A circled up there? A was 2 out of 12? 2 out of 12. B's 2 out of 12. C's 2 out of 12. And D must be 6 out of 12. Right? Yep. So each of these guys has 1/6 of the power, and the senior partner has half the power. That's kind of surprising, huh? It seemed like a really small rule, just, hey, in the case of a tie, senior partner's got it, but really that gives him half the power. Makes a pretty big difference. And the other partners only have 1/6 of the power. See how the math sheds some light on social structures. Make sense there? That was a little weird. Play back the YouTube later if you're confused by that. Think those. I wish I had time to go slower and do 3 or 4 of them, but we got other things we got to do. So I'm going to move ahead on that line. Good? All right. So we finished this chapter, chapter 3 that we're on now. It's on exam 2. It's probably the hardest chapter. This is like probably the hardest one, this chapter. Most people feel this is the most difficult. Carmen and Jorge. So I say that to comfort you. This is the top of the mountain. It's downhill after this. So it's those chapters. Chapter 2's got tough too. All that bond stuff was tough. 2 and 3 are some of the toughest. There's easier stuff ahead. Carmen and Jorge jointly buy a chocolate strawberry mousse cake for $72. Suppose that Carmen values the chocolate cake 3 times as much as she values strawberry cake. Use this information to answer parts A through D. A through D. What are we doing in this chapter?
I'm assuming we're gonna, since I'm looking at the cake right here, it's like halfway split. We split the 36 in half and basically multiplied that half by 3.
Well, I'll get to the details. Let's talk about, you're right, you're kind of on the right track here, something like that. Let's talk about the big picture first off. Remember what we're doing in this class. You want to get a bachelor's degree, so no, I don't mean all that. I mean, we're trying to, that's what I really hear, Mr. Aaron. I know. But the purpose of this class, beyond that, is to say, how does math affect the real world? What are some uses of math in society? This one is fair division. Fair division, like, very, very practical. People divide up things all the time, right? And they want to do it fairly, at least supposedly they do, right? So what we're going to see, this is a very practical chapter. It can be kind of tricky too. But like when an inheritance happens, this happens all the time, right? Parents die, kids get the inheritance. You think, well, that's easy, just divide it up evenly. Well, really? What if you have one super expensive car, right? They had a Mercedes or something, right? And then the big expensive house, and that's it. And then there's 3 kids. You got 2 expensive items and 3 kids. Well, of course, you could sell everything and then just divide up the cash. But what if the car is like really precious to one of the kids? He grew up with that car. He always wanted that car. To him, he's like, no, don't sell the car. That car's worth everything. So anyway, long story short, is there a way where you can divide up things fairly with people when realizing this, different people have different value systems. You know, right? Not everybody feels the same. Like here, right? One person likes chocolate more than the other. Some people like veggie food more than meat food and vice versa, right? There's different value systems. So when you're breaking something up fairly, what does fairly mean? Well, it has to be fair in the eyes of the receivers, or it isn't fair, right? That's determined by the value system of the receivers. So you can already start to sense the complexity. Let me start with the really easy one. Have you guys heard before of how you divide up, say, the cookie? That's not a very round cookie, but anyway, we'll say we got a cookie. We have lots of cookies. My wife is very kind to make lots of cookies. So, cookies in the house, and there's 1 cookie left, right? And you got 2 kids that want the cookie, right? Have you heard this before? It's not just my little thing, it's kind of a famous thing, about how you divide up the cookie. How you get those children. Of course, the parent can cut it, you know. But if you cut it, they're always going to say, oh, Abby got more, oh, John, all that kind of stuff, right? Do you know how to silence all that? Have you heard the famous thing? It's not my idea, but it's well known. You say, one child cuts, the other picks. Do you feel the force of that? So, and I've done it. It works beautifully. Johnny and Abby, they're 10 and 13 now, but I did like 3 years ago when they were 10 and 7. So, you know, and they're arguing about all this kind of stuff, and I'm like, all right, Johnny cuts, Abby picks, right? Abby's little sister, 3 years younger. Johnny cuts, Abby picks. So Johnny gets the knife out, right? Think about how Johnny's feeling. He's about to cut the cookie. He starts to cut, and he goes a little bit this way. And Abby's eyes are like, yeah, I'm picking this side, right? Because she's going to pick whichever two she wants after Johnny's done cutting. And all of a sudden, Johnny's a surgeon. He's coming back. Oh, and he's just like, oh, I'm going to be so. See, the force of being right in the middle is on him because she's going to, if he goes one way or the other, she's going to pick the bigger, right? It works beautifully. So that's the kind of thing we're doing in this chapter. Ways to force things to be fair. Ways to take people's self-interest and make them be fair because of the system you set up. That's the trick of this chapter. How can we use math to make things, inheritances from parents, breaking up land? I'm listening to, I love history, and I'm listening to Winston Churchill's biography as I drive around in my car. I always throw in the next section of it. Anyway, and it's talking, they're already talking about dividing up, they're in the middle of the war, but they're already talking about with America and England, how they're going to divide up Germany and Japan after the war, right? So people divide things up. In Russia, they want a big chunk of it. So anyway, so they're talking about that. So how do you divide things up in a way that's fair? Very much a part of life. How can math come in and help that? All right, so let's take a look here at the cake thing. It has to do, first off, with how people value things. Different people value different things differently. So the cakes were $72. Carmen likes chocolate 3 times as much as strawberry. That's pretty much how I feel too. Chocolate 3 times as much as strawberry. I'm going to put the chocolate here and strawberry here. Okay. Use this information to do your thing on the problem. Okay. So here's what you do. When they give you some kind of thing like a cake like this, and they tell you about Carmen's value system, put it down with letters. It'll be helpful. It'll be easier. What is Carmen value? Chocolate 3 times. So I'm going to go 3x and x. Does that make sense so far? Carmen feels about the chocolate half that is 3 times as valuable as the strawberry half in her value system, her eyes. 3x and x. And what's the cake worth altogether? What's the total? 72. So x plus 3x must make 72. In fact, let me bring it over here. There's a little more room. X plus 3x is 72. Tracking with me? See what I'm doing? I'm just putting down their value system. Carmen. I'm just doing Carmen right now. I don't even know how Jorge feels, but I know about Carmen. She values chocolate 3 times as much as strawberry. 3x and x. And I know the total, they add up to be 72 because that's what the cakes were. That's expensive cake. Okay, so now, you can do a little algebra. Remember your algebra days? Those glorious algebra days? Or maybe they weren't glorious. I don't know. So how do you add x and 3x?
You divide 3.
X and 3.
Got to add them first.
There's just a 1 in front of the X. So
Exactly. There's an invisible 1, 1x and 3x, 4x. Remember that kind of thing from algebra? Invisible 1, add them up. How do you solve for x? Divide by it. What is that, 18? 18 it is.
Oh.
Right? Now what does that mean? What does that mean that x is 18? Well, that means this x is 18, and the other is 3 times 18. Does that make sense? I'm just plugging the x in now to the 2 halves of the cake. Remember, the strawberry was just x, so it's just 18. The chocolate was 3 times x, so it's 3 times 18, whatever that is.
Plug in the X first.
Plug, yeah, once you get the x answered, right on. You just plug it in, plug it in. 3 times 18, 30, 24, 54? 54. That means the chocolate half to Carmen is worth $54. Oops. The chocolate half to Carmen is worth $18. That's how Carmen sees it. Total, if you added those up, the total would be 72. And it's 3 times as much for chocolate. See how we were able to do that? That's how Carmen feels.
Pretty good.
So here comes the questions now. Find the dollar value to Carmen of the chocolate half of the cake. If you gave Carmen the chocolate half, said, here you go, Carmen, here's the chocolate half, she would think she was given how much money worth? $54, right? Carmen thinks the chocolate half is worth $54, doesn't she? Let's go back. We got to get to A, B, C, and D. All right, so here we go. Let me explain these other parts. So remember where we were. Where were we? What did we have so far? We had the cake thing. We had the chocolate half, strawberry half. We called this X and 3X. We did our little algebra. X plus 3X equals 72 total. So that's 4X, because, it's 1X and 3X. Divide by 4. X came out 18, and then we plugged that in. And so this half was $18. This half was 3 times 18, $54. That's where we were. And so we answered $54 is the chocolate half, $18 is the strawberry half to Carmen. That's how she values it. Now, how about this? Find the dollar value to Carmen of the slice of strawberry to the right. That slice of strawberry. Well, notice they're telling me it's a 60-degree strawberry slice angle. Now, we're not going to do hardly any geometry. You don't got to know a bunch of fancy geometry. All you got to know is, do you remember like how much degrees is in that angle?
Right angle.
It's a right angle. It's 90 degrees. Remember, how much is all the way around? 360. That's about all you got to know. All the way around is 360. And so what that means is, let me draw the cake again. Draw the cake again here. You just take those angles as what portion they are, So if all the way around is 360, then this right here is halfway around, right? This must be 180, and this is another 180. It's half of 360. Kind of getting scribbly there. Are you with me? 180, 180. The top half is 180 degrees. It's half a circle, half of 360. The bottom is 180. So when they tell me 60 is what portion of 180? It's a third, right? 60 over 180. If you reduce that fraction, if you divide in your calculator, divide top and bottom by 60, you'll get 1/3. So that means this 60-degree strawberry piece is 1/3 of the entire strawberry piece. Are you tracking with me there?
But the strawberry piece is 8.
So you got to take 1/3 of $18, which is $6. So I'll write that out. But you see where I'm going? So I took their angle. So what you do? Let me write this out. I know this is a little tricky. This is the part that there's a few parts in this chapter that are tricky. So how do you do the angle degree thing? You just take. Let me come up here. I'll come up here where I have some room to work. You just take the 60-degree angle and divide by 180, which is 1/3. Why 180? Because 180 is the whole strawberry, right? 180, here's the strawberry, the chocolate, right? The strawberry is 180 degrees. So we're saying, well, that's 1/3 of the whole strawberry. 60 is what part of 180? It's 1/3 of the whole strawberry. So 1/3 of the strawberry, that's what this is. So and what does of mean? Of in math always means multiply. So 1/3 of the strawberry is 1/3 times the strawberry. And what's the strawberry worth? $18 right there. 1/3. So you just take your calculator, 1 divided by 3 times 18. Yeah, which just comes out $6 when you do the whole thing. Or just 18 divided by 3, same thing. $6. So that means that little strawberry chunk there is worth $6. Really, you see 3 of them could make up the whole strawberry half. 6, 6, 6, 18. So that piece would be worth $6 to Carmen. See how I did that? And then part D, say that now they're giving me a 45-degree chocolate piece. In fact, you know what, guys? To make it even easier, here, let me make it even easier. I can make it one step easier. All you got to do on these angle things, come on. All you got to do on these angle things, let me make it one step easier. On the strawberry, just take the 60 over 180 times the $18. Because it'll get you straight to the $6 answer, right? Because that's the portion, right? That strawberry piece is 60 out of 180 times the whole strawberry is worth 18 bucks. Gives you $6. Now, try that for the chocolate one.
So we're gonna do the same thing.
Same thing. Chocolate, it's a 45-degree chocolate piece, part D. 45-degree chocolate piece. So how big's the whole chocolate? 180. So you take the part. Part always means part over whole. So it's going to be 45 over 180, isn't it? Times the value of the chocolate. What's the value of the chocolate? 54, isn't it? The chocolate half is worth 54. Right? So I'm taking the strawberry half, chocolate half. So it'd be 45 over 180 times 54. And that gives you the 13.5. See how I'm doing that? The chocolate is 45 out of 180 times the value of the chocolate half times the 54. $13.50. That's what that's worth to Carmen. That 45-degree chocolate chunk. Is that good?
You said how many slices and a half?
What's that?
How many slices was it a half?
So I was doing it a different way before. This way I just took the direct angle of the 45. I just put it over 180 because 180 is the whole half. So just put whatever angle over 180 times the value of that half, times the 54, which is what the whole chocolate half is worth. That's all you got to do. So for the strawberry, I put 60 over 180 times what the strawberry half is, 18. So just put the angle over the total angle times the total money for that half. That's all you got to do. Because you're taking that portion of the value. Good afternoon, Mr. Dorn.
Very nice. I love the use of color.
Thank you. Yes. I stop at nothing. All right, we good? On that? All is well? All right. So remember what we came up with, guys. We just took, however many players, just 1 divided by that is what's fair, right? Does that make sense? If I was in a group of 4 people, and we were eating cake, I would think I was treated fairly if I got 1/4. Right? It's always 1 over how many people. That's our sense of fairness, right? So 3 people, 1 over 3, 33.3. So I circled all the numbers that are over, not 33 right on, but over 33. Those are the ones they would feel they got a fair shake if they got those. Now, let me ask you this. How could we pass out those 3 pieces so that everybody felt they got a fair share? Which one could we give A so he felt fairly treated?
Y.
He'd have to get Y. We can't give him X or Z. Only one he thinks is fair is Y. How about person B then? So we gave away Y. Person B, we'd have to give what?
Y.
The Z, because the Y is already gone. We gave it to the person A. Have to give him Z. And then C, all we got left is X. They don't want X. There's no way. With their value system, there's no way we're going to treat everybody fairly. At least with the way the cake was cut. We would need a different cut on the cake. With that cut of the cake and how they value things, it's not going to work. Do you see that? There's no way to be fair. There's no way for... Nobody liked piece X. So nobody's going to want that piece. So there's no way. So that's the 4th question they're going to ask you is there a fair way to finish this up? No, not this one. We would need a different cut on the cake. Is that good? So number 4, Jared and Carla, they're gonna buy their veggie meatball sandwich thing. So how should Jared cut the sandwich into 2 shares? Oh, that's all they're saying. How should Jared cut the sandwich? All right. So here we go. So Jared and Carla are eating this sandwich. It's a 24-inch sub. It costs $9. They're going to divide it fairly using what's called the divider-chooser method. That's the cookie cutting thing I told you about, where one person cuts, the other picks. Johnny and Abby. Johnny cut, Abby picked, right? That's what that is. That method is called divider-chooser, meaning one divides, the other chooses. Divider-chooser. So whenever they say divider-chooser, now again, let me tell you about my kids, right? If I have the cookie and I say, Johnny, you cut, Abby's going to watch, and when you're done, she's going to pick which side she wants. What is that going to make Johnny want to do as he cuts?
Split it.
Really fair. Right? He's like a surgeon. He's going to want to be really fair, because Abby's gonna pick whichever she wants. So the point is, whenever they say divider chooser, you should think, oh, the one cutting it is gonna try hard to be fair because he knows he gets last pick, right? That's the main principle. When they say divider chooser, you think that cutter's gonna cut it fair in his value system. Careful now, not everybody values the same, right? So the divider, the cutter, will cut it fair as he values things. He'll make it 50-50 when he's done because he gets last pick. All right, so with that in mind, that's what they mean when they say that. And that's true to life. I've seen it. Jared makes meatball subs 3 times. Jared, how does he feel? He likes meatball subs 3 times as much as vegetarian. 3 times as much as vegetarian. That's how Jared feels. So, I could put 3x and x. Meatball sub, right? That's how Jared feels. Carla, she has a different value system, but we'll get to her in a minute. We're doing Jared right now, the cutter. So there's how Jared feels. 3x and x. So what are we going to do with this thing?
It's a big sub, I'll have to say.
Let me help. This is a tricky one. I think here's the easiest way, I think. Just break this sub. Let me make it longer here. Here's the 12. That's a 20. It's a 2-footer. 24 inches of 2-footer. Anyway, so there it is. Okay, this whole side is x, and this side is 3x, right? This is the veg. This is the meat. Right, you with me? That's how Jared, I'm doing Jared's value system right now. He's the cutter, so he's the one I'm focused on. So x and 3x, that good? Now, the trick is, what's Jared going to do? Jared's the cutter. Jared's got the knife. What's Jared going to do?
He's probably gonna cut it more
Cut more.
vegetables.
He's going to cut it fair in his eyes. Because his sister Carla is going to pick which half she wants. Right? Jared's going to cut it fair in his eyes. Because he gets last pick. Remember the cutter? Gotta remember that principle. The cutter gets last pick. So he's going to cut it fair in his eyes because he gets last pick. So in his eyes, well, for example, he cut it right in the middle. Would he do that? Would he do that, for example?
No.
No. Because he would think the meat one's way better. Right? And he would be scared that his sister would pick the meat one. And he would not get half the value. Remember, he gets last pick.
No, his sister.
So he would not cut there. You see what I mean? He would cut more to the right, wouldn't he? So that he got all the veggie, which is only worth x to him, and some more meat somewhere over here, where the 2 parts after the cut will be equal value to Jared. All the veggie and a little bit of meat, we got to find out how much little, will be equal in value to the rest of the meat. Somewhere over here. Does that make sense? So that they're equal value to Jared, so he doesn't care. Pick whichever one you want, Carla. I'll take the leftover. They're equal value to me. I cut them that way, right? That's what the cutter will always do. So how do you know where that is? Well, how much x we got all together? Do our algebra. 1x and 3x? 4x. 4x, cut it in half, 2x, can't do my fingers like 2x, 2x. It's going to be 2x, 2x, right? So we got to cut 2x, 2x. Well, how do you do that? Well, this is 3x, and it's how long? It goes from 12 to 24. How far is that?
12 inches.
12. That's 12. Cut that into 3. Divided by 3? 4 inches apart, right? So my point is, go every 4 inches. Go 4, go 4. So 12, add 4, 16. Add 4, 20. Add 4, 24. Let me slow down. You see what I'm doing there?
Oh, you're breaking up.
I'm breaking that x into 3 x's equally. Right? That 3x, the meat part, I just divided the 12 by 3 because it goes from 12 to 24. That 12-inch meat half, from 12 to 24, the 12-inch meat half, I divided by 3, got 4, so it's 4 inches, that's an x, 4 inches, right, 12 to 16, 16 to 20, 20 to 24, 4 inches, 4 inches, 4 inches, x, x, x. That's how Jared valued. That means 3x for the whole meat half. Now, do you know where Jared's going to cut? He wants to cut somewhere so that there's equal value on each side. He's going to cut right here, isn't he? Because that'll put what? 2x on this side and 2x value. Now they're not equal size, but they are equal value to Jared. 2x on each side. Do you see that? Because he likes meat more. So getting 2/3 of the meat is worth as much to him as all the veggie and 1/3 of the meat. How do we know that? They told us. He values meat 3 times as much. So there's 3 x's over here. So cut it, so 2x, 2x, according to his value system. There's where Jared will make the cut. Because then they'll be equal to him in value, and he won't care which one Carla picks. Do you see how we figured that out? So he's going to cut at the 16-inch mark, isn't he? You see that? He's going to cut at 16 inches. Right? This is 16 inches. That's where he makes the cut. And that'll put x and x, 2x, the whole veggie and a little bit of meat, 2x, and the rest of the meat, 2x. Equal value to Jared. Equal value to Jared. So, determine how Jared should cut. He'll go to 0 to 16. There's option D here. 0 to 16, right? That's where he'll make the cut. Option D. 0 to 16 and 16 to 24, right? One piece will be 0 to 16, the other will be 16 to 24. That's where Jared will make the cut. Because that's equal value to Jared. And he won't care which one Carla picks. That's what the cutter does, who gets last pick. Good to there? All right, let's try. Let's see what else they're going to ask. What else are they going to ask? Go back here. Okay, so that was right, the first answer. Now, the second question is, after Jared makes that big old cut right here, Jared makes the cut. He says, all right, Carla, pick which half you want. Do you want this big chunk here, or do you want the one that's just all meat? The 2/3 of the meat, or the whole veggie and the 1/3 meat? What do you want? Well, you tell me. Look at Carla and put on Carla's glasses for a minute. What does it say about Carla and what she values? Carla is a vegetarian and does not eat meat. So when you make a cut right here at 16 and you offer Carla either this side or that side, which side is she going to take? She's going to take the veggie, right? She's going to take the veggie and the 1/3 of the meat and throw away the 1/3 of the meat and just eat the veggie because she doesn't eat meat, right? So really, stop for just a second. This is kind of dumb. I mean, really, isn't it kind of dumb?
Why do you have to do
No, wouldn't it be better if they just talked and got along?
You like meat?
And say, yeah, I like meat. Well, great. You take the veggie out, I'll take the meat. We're all happy, right? So so let's keep that truth before us. That the best thing in all situations is to talk and care about the needs of the other person. But real life isn't always that way, right? Inheritances, children, all kinds of problems. They're not always wanting to talk and wanting the best for the other person. No. So these math rules are really only useful in hostile situations, right? I mean, if there's not hostility, who needs the math? Just talk and be kind to the person. And you'll probably get more in the long run. You get the whole, Jared would have got the whole meat thing. So, right, but I just want to be clear about that, right? Real life, there are a lot of hostile situations. When Churchill was talking to Stalin about how they're going to divide up Germany, they don't like each other, Russia and England, right? There was no, oh, Churchill, I like you. What do you want? No, there was none of that, right? There was hostility and all that stuff. So, and inheritances, and many times in life, it's not that way. So that's the purpose of the math, to force fairness even when my Johnny and Abby aren't loving each other at that moment, right? I can still force fairness. So, that's the purpose. All right. So, that's what Carla would pick. She would for sure pick the veggie half. Now, final question is, how much is that worth to Carla? Was it worth to her? Is that what it said?
Yes.
Yeah.
How much is it worth to Carla? Yeah, so how much would that half, this half that Carla will pick, how much is that worth to her? Remember, the whole sandwich is worth $9. Careful now. It's going to be a simple answer once I give it to you, but think with me. You don't need to do any fancy math. You need to put on Carla's glasses and think like Carla thinks. She and Jared maybe paid the whole $9 for the sandwich, $4.50, $4.50, whatever they did. They paid $9 for this sandwich. Carla thinks meat is trash. She's going to throw away the meat. Doesn't eat meat. Everything is veggie to her. The only value is veggie to Carla. So what does she think about the value of the piece she got?
Less than half?
It's $4.50. Wait a minute, would it be $4.50?
It's $9. It's all the value to Carla. She thinks that meat is trash. She doesn't care she didn't get any of the meat.
She doesn't value
She
it.
doesn't value. When she paid $9, she had her eyes on the veggie alone. Right? The veggie is worth it all to her. That's her glasses, right? She thinks only veggie is valuable. So the veggie to Carla is worth the whole $9. This is trash to Carla, right? So you don't need to do any calculation. You just need to have Carla's glasses on. $9. Carla will think the left half is worth $9. Does that make sense? Or even just the veggie part's $9. The meat is trash to Carla. How about Jared? So Jared will get the right half, right? Jared will get the right half. What's that worth to Jared? The right half. Before you do any fancy calculation, don't need to do any math. You need to remember the process. When I tell my two kids, one of them cut, the other take, what is the cutter going to do? Remember, Jared was cutting. What is the cutter going to do? Fair in his eyes. He's gonna, because he's scared he gets last pick. So whatever he gets, whichever of the two he gets, he thinks he got it exactly 50%. He cut it that way.
So half.
So exactly half. I don't need to do any fancy math. The whole thing's worth $9. Jared was the cutter. The cutter always cuts it fair. So Jared will get half the value. Either half. So he gets $4.50. Half enough, right? No fancy math, just understanding what a cutter will do in real life and how Carla values things in real life. That makes sense? So Carla gets $9. Jared only ends up getting $4.50 worth of value because he just wouldn't be nice to his sister. He only gets half the value, and Carla steals the day. All right, well, that was a lot of math there. We almost finished 3-1. We didn't quite finish 3-1. So, yeah, we were supposed to finish 3-1. We didn't quite, did we? And we have the exam tomorrow. All right, so, no, practice exam tomorrow. Yeah, practice exam tomorrow. It's an important difference, huh? All right, practice exam is tomorrow. Yeah, so the homework then, let's just do 2.2 will be due, what's tomorrow? Thursday.
25th.
Tomorrow, yeah, whatever that date is. So 2.2 is due tomorrow. Let's finish up with a quiz. I always finish up with a quiz. Did I get... Adrian, do you have your clicker? Oh, you don't got one? Okay, can you hang on after class just a second? So everybody else got their clicker, right? So let's click in. Clicker. Oh, wow, you're quick. All right, well, let me enter your number in there then. Can you see on the back that little code? Is that what it is? Yeah. Let me see, where are we? Oops, I'm on the wrong thing here. There. Jenna, right? What's your number there, Jenna? 9D7. Oh, well, let me do it again. 9D792C. 9D792C. All right, looks right. Save and close. Okay, so let's do this then. Okay, so polling, all right, we are running
How does it work though? Batteries don't work.
polling A anywhere.
EPA.
All right, I'm gonna do the same thing I did a second ago. We don't have time for an efficient, I normally begin with a quiz question. I often end with a freebie. You're getting both freebies today. So click A again. So just click A again. We don't have time, we're out of time. Click A for Apple. A for Apple. I think there'll be 19 of you now. 18? Something like that. I can't remember. Everybody in there? A for Apple? A for Apple? Everybody in there? And we'll be done with that. Everybody's in, right? Last call. A for Apple. We're all in. Close her down. Yes, 100% got A's. All right. So that's free 10 points again on the end. So tomorrow we take the practice test and do some other stuff. Have a good afternoon. Hang out if you got questions.
See you tomorrow.
That's my water bottle.
Oh, is that your water?
Thank you.
I was drinking out of it. No, I'm just kidding.
I saw the batteries right there by the.
Oh, yeah, your code thing, huh?
Yeah, it's like
Yeah.
asking me to show you.
So I give you that number. Where'd that number go?
This is my username and password. I want to see if it works.
Sure, sure. Look on there. Let me save this first.
That's crazy.
Quiz 2, let's say 24th. 24. Okay. Station is sport. Did you have one? You don't?
I got one now.
You got one?
Yeah, one of the students gave me the extra one. Yeah.
Oh,
But it
okay.
needs a battery though.
Oh, it doesn't have a battery.
Yeah, I don't got a battery.
Oh, gotcha. Okay. So, do you want to give me the number on the back? Or let me
Yeah.
edit that. And what you got, Adrian? Back there. Let's see. Oops. 98E927, I think. 98E927. Am I reading that right? It's my eyes are getting old. 9AE927, is that right?
9AE927.
Good, okay. Good,
I
okay.
can't see my damn self.
And let me export that to directory. Did Jenna, did yours work when you clicked it?
No, it hit I saw red when I hit the A,
Oh.
so I'm not sure what happened.
Okay, let me see. Movable disk, okay, save. All right. Yeah. All right, so, what I can do. Here, can I see, is it, see it's on the right channel or what it's on? Yeah, it's on 41. Right, put this in. See if it works here. We go to polling, A on anywhere, and boom. Yeah, took it just fine, huh?
Oh, it did?
Yeah, just now, so it's
Oh,
working.
just now. Okay, good.
Yeah, it's working, so, let me see, it probably didn't do this one. Let me see, results manager. Oh, that was the old one, yeah. I want to do session, import. Oh, that's the other thing, right. So, session. It's two, right? Jenna. Oh, yeah, so it didn't take it, okay. But you got it, so I'll give you credit. I'll go back and give you credit. You got it. For whatever reason, didn't take it. Yeah, next time, just make sure it does do green.
Yeah.
And then it's got your, and if it's having trouble, just let me know. If
Okay.
it's not taking it.
I will.
Must be just, I don't know, it was blocked or something, but it's working fine now.
Okay, sounds good, thank you.
Yeah, oh, so you got one, Adrian? Good deal, good deal. That's all. I just want to make sure
Okay,
you
I'm
knew
set
you need to have one. The quizzes, yeah.
Okay, so
Good. And I
I'll
saw
go
you
get a
got Math
battery.
Excel. You're online with that,
Yeah.
so you're good. That's all. Just want to make sure you're able to get one.
Appreciate it.
Yeah, all right. I sent you an email. Those YouTubes are up there if you,
Yeah, I watched
yesterday's
I
lecture.
watched yesterday's.
Good. Making sense for you?
Yes, sir.
All right. Yeah, I want to see on the Math Excel. Sure, let me see if I can help. Let's see. One here, there's the number I got for you. So, okay, let me go back to, well, let me see first off, are you on my grade? I don't think you're there yet. I'm on Math Excel.
I had just.
What's your
signed
last
in.
name? You are,
Alvies.
yeah, you're not up here. You'd be right in the beginning, huh?
Mm-hmm.
Yeah.
I had just signed in on the library, and they gave me some tutorial about like trying to type the code in. And I
Okay.
looked at my bag. I didn't have my paper.
So you, so did you pay with your credit card and everything, or did you got to that point?
Yeah.
Okay, and somehow it, oh, and did you type in the, this thing and it wasn't working?
No, I didn't type it in last night. I tried to do it this morning in the computer lab, but
Right, and how far did you get, like, in the process, did you like answered these questions and that kind of stuff?
I got all the way into this. I typed it in last night, but
Oh, you did type that in?
this morning, like, it said I had to type it in again, but
I don't know. Yeah, I mean, I could, but you gotta go to a class, I know. So, yeah, I would, I just call them with that number I gave you, that 1-800 number. It's probably, maybe you, maybe you forgot your password or you got it wrong a little bit or something like that. That's usually what happens.
I had to try it one more time.
Sure, yeah. So like registering in? Well, if you never typed this in, you never typed that in or you did?
No, I didn't.
You did not?
I did. I did it on phone.
Yeah.
So I don't-
Oh, you did it on the phone with a person?
No, I did it on the phone, like on the internet, on my phone.
Yeah,
Like on
yeah,
the-
oh yeah, gotcha. And you typed this in though, this code, did you actually get to that code eventually? Because that's the end of the process, that's why I'm asking you about that. Did you actually get that and,
Somebody
do you not
did it
remember
for
exactly,
me.
or-
I like did try it again, cause I don't
yeah,
know.
sure. Yeah, you wanna, feel free, or here I can, what is it? Or actually, you need a password and everything. Go ahead, I'll let you type that in, see if it goes in there.
Kept saying it.
So somehow, yeah, it doesn't have that right. So what you could do later this afternoon is just give them a call at that number, say, hey, I paid for the thing and everything. Here's my username. It's what's going on, and
Yeah.
they'll help you get
Alright,
that set
Carl.
up. So yeah, so I won't drop you. You're working on that. Yeah.
Try it right now.
change.